Hey Gurus, welcome back. It's me again. Welcome back to the second part of C# 4 pen testers. In this session, we are going to explore the classic process injection technique and shellcode encryption and decryption using XOR. Let me take you to the code directly so I can explain a bit more. First, we will go explore how we are going to encrypt and decrypt using the XORing. I hope you remember last video we did encryption using AES 256, where we reduce a key and an initialization vector. But for XORing, we just need only a key. We don't need any kind of initialization vector. Uh, just here, we are going to use the encryption and decryption first to ensure that our encryption and decryption is working fine. Then we will be, uh, after ensuring that algorithm is working fine, that we supply the same encrypted shellcode to our process injection application. So that has the decryption technique implemented. So it will work fine once we confirm here. What I'm going to do here is I'm going to generate the shellcode for us first. Just check the IP. It's 192.168.1.72. So hopefully it didn't change from the last. Yeah, we are going to use the same interpreter reverse HTTP payload. IP didn't change, so port is 443. I'm going to make that shellcode on C# format. Yeah, it did for us. We are copying this one, and what I'm going to do is mousepad. Yeah, I'm going to edit shell.txt. I'm going to share this with my coding machine so I can make use of. I can take it there on the coding machine, and I can supply that as an input to the encrypt application. So just ensure that oh, Apache has started. Yeah, it's running from here. Yeah, it's I already accessed for the previous example. Yeah, I'm copying the shellcode. Just is F5. Just checking. It's yeah F5. Coming here, I'm going to use that shellcode encryptor here using the XORing. Here, this is a XOR encrypt and decrypt. What happens when you have XORing on a byte? When we are XORing on the byte with the same key two times, or again, like once if you encode one set of byte using the XOR, we get a result of ciphertext. And for decrypting, we have to do the same operation on the same set of bytes using the same key. You will get the plain text. So it's very easy process compared to other one, but it's a very strong encryption technique. So here I'm going to use this key. This key I have generated on my previous application. I have showed the automated way of generating this one using another application, and that app is here. Um, Keygen. Uh, don't worry about this app. I will upload all this solution to my GitHub, so you can try yourself. Either you can make use of that, or if you want to make use of your own key, don't need to use base64. You can just use ASCII get bytes from the ASCII encoding class, and you can make use of your own key. Here I'm going to use this key. That's the one that I used last time. And let us try what happens when we are going to encrypt it. Yeah, this is the encryptor result. I'm just copying it for future use. Just to here, I'm just ensuring that the encryption and decryption works fine. This is the encryptor result. So we are going to supply this encryptor result as an input to our decrypting application. And one thing you have to ensure that we are using the same key. uh, Basically I just copied from here, so but I'm just double checking it. Yeah, we are just using the same key. So uh, as I said, we are using the same technique to decrypt it back. We are XORing on the same set of bytes to get that original bytes back. So after pasting that, I'm just clicking on decrypting, and here is the decrypted shellcode. So this should match the original shellcode. In fact, the original shellcode is just check it, 4831 C9 48, 4831 C9 48, and the last one is 55 Fi 55. Yeah, it's done. It's working fine. So the next thing is we will supply this. Here we are not doing the process injection. This is a thread injection we did last time, the classic P injection. So today we are going to do the process injection. So come here on the process injection area. Well, for doing the process injection, we are going to make use of four APIs: open process, virtual X, write process memory, and create remote thread. I will explain this with the help of code. It's basically just a high-level explanation I can give you. Open process will open a process for you and gives back a handle, and we will be using that handle to allocate a region on the same process, a memory region on the same process. That region we have read, write, execute access right, and then we use write process memory. Uh, Write process, what exactly write process memory is going to do is going to write our shellcode into the region that we allocated using the virtual X. Then we use create remote thread uh, API to execute our shellcode. All these are interconnected. I will show you using this example. Here on the first example, we are going to create a new process and inject the shellcode into the same the process that we create using this uh, get process by name and open process and other APIs. First, we create a notepad process, then we get the handle from ID from that using the get process by name. Then it returns an array of processes. From there, we take the first process and take the ID, and we supply the ID to this open process. And open process will give back a process handle, and we use the process handle to the virtual X to create a memory region for us to inject our payload. So the virtual X will give back a base address to this memory region, and we use that base address and the process handle to write our shellcode to this region. So before writing the shellcode to the region, we do decrypt our encrypted shellcode. We just pasted our encrypted shellcode here. Did I paste that? Oh, it's 35 XCF. It's 2F. I didn't paste that. It's a previous value. Hopefully this is the one. I'm just giving that encrypted XCF just to ensure one more. I just forgot that. Yeah, S05, S05. Yeah, the shellcode is same. Just double checking it. Just copy this. This is a decrypted shellcode. uh, this is encrypted shellcode. So we are supplying our encrypted shellcode here, and we are decrypting the shellcode before writing into the process memory that we created using the virtual locx. Then finally we create remote thread using the process handle and the base memory address that we created, and we are writing our shellcode. We are executing our shellcode. We already returned the shellcode into the process memory using the right process memory, and finally we run the shellcode using create remote thread. So this is a process that happens, and it's pretty straightforward. And the first example, we will create, as I said, we will create a new process, and then we try to inject into that process. So, before starting, before supplying that to uh, the victim, we just open our server here. Before that, just ensure that this is same. Yeah, IP and the payload are same, and the port are same. So we can just start it. Now our server is running there. So next thing is we have to build our decrypted application, process injection application. Now the process injection and the decryption is happening on the victim machine while running this application. So let me build this application. The name of this application is process proc inject. Just come here and I'm just rebuilding proc inject. Yep, I'm inside this proc inject x64 debug folder. Uh, while testing on real time, you can make it use of the release mode, so you don't need to carry the debug flags with the exe. Yeah, copy the project.exe to. This is a folder I have shared with the victim VM virtual machine. So now I'm going to copy. I have mapped the virtual VMware shared folder here as a Z drive. I just did that for the demo previously. Just doing it again. I have the file here. So hopefully what's going to happen here is it will start a process notepad.exe. Then we will be injecting the decrypted payload into the notepad.exe. So at the same time we'll be getting back connection here. We have the fully controlled meter shell here on that CNC machine. Here is the Kali Linux machine that I'm using. So let me open it. Yeah, this is an actual decrypted shell code. Uh, Hopefully this is working because I don't do this in real time. I just did just to ensure that the shell code decrypted is correct or not. It's a correct one, I hope. And we opened a notepad. The application opened a notepad process. And let us come here. Yeah, here we got the sessions-i and the first session. Here we have the fully fully functional meter session. So just do the shell command, you'll be into hopefully. Yeah, uh, this one will work till uh, till you close the notepad.exe inside this victim machine. So when I close this one, I'm just closing this one. So basically, the shellcode we injected was into the process of notepad.exe. So here if I try the shell again, see it won't work because we already lost the session, the actual session, just because we were into the notepad.exe and we closed that exe there. See, it's returning an error. So the next thing what we are going to do is, instead of notepad.exe, we'll be injecting into the explorer.exe. So what's the benefit of that one is, normally nobody's going to close that. It is the exe that helps you to see what you are seeing on the windows. So we will be doing that next. Let us run our server here. So let's go back to the source code. So here we created a new process and we did inject into that. Instead of that, we are going to get the process ID of explorer.exe. This is not the notepad process ID, this is explorer. Oops. Explorer process ID, and we are supplying that to the open process handle. So instead of creating any process like notepad.exe, it is going to inject into the current already running explorer.exe. The process, rest of the process is same, everything is same. Only the difference is here we are going to inject into explorer.exe. So let us build this application, rebuild this one, and after rebuilding this, hopefully everything is working fine. I did the right, yeah. Inject, come here, yeah, yeah, it's 32, yep, it's correct. So I'm going to copy this, replace the previous one, come here, close this, delete this one, copy the new project.exe here, and here this is not going to open any notepad or anything. Here is, it will be silent, and this will be going to inject the shell code, the encryptor shell code, to explorer.exe. That means here. Uh, so let me open this. Yeah, it's decrypted shellcode. Let's go back. See, here we have an active session. Sessions -I this one shell. See, the difference between the previous one and this one is, previously we created a process called notepad.exe on the victim machine, and we injected our shellcode into that. The demerge of that technique is that the user or the victim had the option to close the process, and once he closes the process that we created using that our application, we will lose the session. But here, just because we injected into the explorer.exe, and normally nobody is going to close that, because explorer.exe is the one that is responsible for. See here, I just forgot to mention that we just closed our actual application. The project inject.exe is closed here. Even after closing that application, we still have the active session, just because we have injected into the process.explorer.exe. So this is the benefit of being hidden inside explorer.exe or svc host.exe, or something that we just try to find a safe process to inject into. Yeah, that's it for process injection. We'll be exploring more on C# for Windows on upcoming sessions. That's all for this session. We'll be seeing with another one very soon. So if you like this video, try to share and subscribe, because I don't know when YouTube is going to close my channel because I don't have enough subscribers. So if you like it, just try to subscribe and share it. See you then on next video. Till then, bye from Alphas.